Swayam Prabha. Digital India. Educated India.
Let me welcome you back in the Industrial Biotechnology course. Now, I shall continue the downstream processing, and in this downstream processing, we will take care two different aspects. One is the liquid-liquid separation process, and what you call distillation process, is largely used by the industry. Now, liquid-liquid separation process usually use where we have partition coefficient of the two liquid is different. As for example, with respect to a particular solute will be different. As for example, I can tell you, in case of penicillin separation process, that we use butyl acetate as a solvent. Now, butyl acetate, when you decrease the pH of the liquid to penicillin solution to 2, the solubility of penicillin in butyl acetate is more as compared to the water. So, when you mix these two layers, then we will find that penicillin will go more in the solvent layer. Then since butyl acetate is insoluble in water, so you can separate, because if you separate the layer, we can separate the butyl acetate from the aqueous phase. Now, if we take water and we increase the pH to 7, then we find that solubility of penicillin in the aqueous phase is more as compared to the solvent. So, the penicillin will go to the solvent phase, the aqueous phase. So, like this we can purify this penicillin, and after that, as you know, penicillin usually marketed in two different forms. One is called in the form of penicillin capsule, and another is penicillin liquid, that fluid, injection fluid. Now, when injection fluid we use, we should imagine that this that directly injected to the blood stream. So, it should be 100% free from any kind of contaminants. It is called pyrogen free material. But when we use this in the form of capsule, even you have little contaminants is there, because since our stomach is acidic pH of 2, it will take care of that. So, anyhow, that now I am going to discuss about the liquid-liquid extraction process, which is largely used by the industries. Now, the separation of basically it says that separation of the two components of a liquid, the feed, by contacting with other second immersible liquid, the solvent. This is the solubility of this solute in one solvent will be more as compared. This is on the basis of partition coefficient. So, the extraction is usually used when direct distillation is not economical. The examples are penicillin, extraction of penicillin from fermentation broth by contacting amyl or butyl acetate, then recovery of acetic acid from dilute aqueous solution by contact with ethyl acetate or ethyl ether, then separation of high molecular weight fatty acid from vegetable oil by contacting with liquid propane. Now, liquid-liquid extraction method utilize the solubility difference of the component in liquid mixture. This is very important. Until unless we have the solubility difference, this method is not cannot be used. So, in extraction operation, liquid mixture is to be extracted is called feed, and the solvent is the liquid which contact with the feed for solute extraction. The extract is solvent rich product of operation containing the extracted solute. This is called the extract phase. This extract phase contains the desired product in large amount. I can give a schematic diagram on that. This is like this is the block flow diagram. This is feed is coming this way and this is solvent is coming, then they are mixing together. And then the separation take place. We have extraction, we have raffinate. Raffinate means, extraction means here we have mostly the solute, here we do not have much of solute, that we present that. The equipment for extraction, industrial extractor can be classified in the following category. One is mix settler, centrifugal extractor and counter current contactor. These are the different techniques that we have that I will explain. And now mix settler is consists of mixer and settler. So you have feed and solvent, both the things we have, we mix it with the help of stirrer, then we settle that, and then the one phase will be separated to other, lighter phase we take it out, heavy phase we will take it out from the bottom. So these are mostly used for metal industry, where high residence time and intense mixing is required for relatively extraction process. This has little application in the biochemical industries, but I told you in the penicillin industry also that your solvent is lighter than aqueous layer, that is go to the top, and the aqueous will be bottom, that also. But this is mostly used for the metal industry. Now centrifugal extractor, we have centrifugal extractor is used for interdispersion of liquid and separation phase. The centrifugal extractor are high speed rotary machine that offered the advantage of very low residence time, and commonly used pharmaceutical industry. Common extraction of this kind is pod bioliang. Now counter current current column extractor, the extractor belongs to this category as the cylindrical cell with the internals. The heavy liquid enters from the top and light liquid from the bottom through a distributor. I can show you. Now I think this will be very clear to you that how it is. So we have this is the spray column. We spray the heavier liquid here, and this is lighter liquid here, and when it goes like this, then they mix together, and this is called, this is heavier liquid from the top and lighter from the through the, this is the counter current column contactor that we have. Now another things we have, that is packed column. Packed column means here we pack the some kind of solid materials, and then heavier liquid is coming here, perforated materials that which has some porosity, then lighter material when they cross each other, then they mixed, they have the intimate mixing, and we can separate that. Light liquid goes out from the top, heavy liquid goes out from the bottom. Now another things we have what we call perforated plate, the sieve plate column. Now you can see that some kind of the sieving plates are there, the liquid is going like this, it crosses like this, and heavy liquid is come. This is also, we can separate the light liquid and the heavier liquid like this. This is called counter current column contactor. Now distillation is largely used by the industry. As for example, that alcohol industry, we largely use this is on the basis of mostly the temperature of vaporization of the particular liquid, that your particular solvent you are going to separate. The distillation in the unit operation separation of two or more liquid components of a liquid solution into more pure fraction. I can give it a simple example. In the alcohol fermentation process, we during the fermentation process, not only the ethanol production take place, but besides ethanol there are fusel oil also formation take place. Fusel oil is nothing but higher alcohol, so that you can separate on in the fractional distillation column. The operation involves the vaporization, subsequent condensation of the liquid. Separation is achieved because of the difference of vapor pressure of the component at given temperature. Liquid desired product is called distillate, and the bottom product is called bottom, or it called raffinate. Now, distillation examples, we have the ethanol and water mixture that is largely used by the industry, because the ethanol has the boiling point 78 degrees centigrade and water has the boiling point 100 degrees centigrade. So, when you heat this solution and we collect the fraction as about 78 degrees centigrade, we get mostly the ethanol, but with the separation process we can get maximum 95% of ethanol. We cannot have more, because at 95% ethanol plus 5% water, they form the azeotropic mixture. It is very difficult, it is not possible to separate. So, if you want to produce the absolute alcohol which contain 100% alcohol, so we use the benzene as a solvent, then and only then we can produce the absolute alcohol. Separation of petroleum crude from gasoline, kerosene and fuel oil also can be done through the distillation process. Method used for the distillation process is differential distillation, flash or equilibrium distillation, and fractional distillation. Fractional distillation is largely used by the industry, so that we can collect the different fractions after the distillation. So, this is the schematically how this process can be explained, that we can heat this and then we pass through this column, and you can see that we can collect it the different fractions that we have. This is one is the column, 2 is the feed preheater, this is the preheater feed is coming like this, and then condenser for the overhead vapor, this is the condenser overhead vapor, this is the 4 is the reflux drum, even the reflux is equal to that, and reboiler partial vaporization of this. So, this is how you can separate. So here basically at the bottom that you get what you call raffinate, that is actually the waste material, that is the unvolatile material that comes out from the bottom, and volatile material we collected from the top. This is a kind of distillation technique that we use. Now, another technique that is largely used by the industry is the chromatography technique. Chromatography is a solute fraction technique that relies on the dynamic distribution of the molecules to be separated between the two phases, a stationary or binding phase and a mobile or carrier phase. So, you know that this is the different type of chromatographic techniques we have. Particularly, I can give you the example of streptomycin fermentation process, where we use this chromatographic technique for the separation of streptomycins. Different substances are separated based on the differential distribution between the two phases. Application is the biopharmaceutical production, biopharmaceutical and biomedical analysis, environmental analysis, diagnostic, and the process monitoring. Now, chromatography, we have the chromatography is the equipment that enable a sophisticated separation. As for example, we have gas chromatography, we have liquid chromatography. The basic difference between the gas chromatography and liquid chromatography is that mobile phase in case of gas chromatography is the gas. So, we use gas as a carrier, because when we inject the sample and then it vaporizes. If it is gas, that gas will remain already in the gas phase. So, but with that gas you have to have a carrier gas. You have sample is the gas, but you have to have carrier gas. That carrier gas will take the sample through your column, where the separation of different components present in the gas mixture that will take place. Then it goes to the detector, where we can detect the temperature. So, in case of gas chromatography, we have three different sections. One we call injector. This is called injector, and another we call oven. where we have column and another we have detector. So, what do you do here? We put the sample, measure amount of sample with the help of syringe, then here we put the carrier gas. Now, here everywhere we can maintain the temperature, we have different temperature control. Here we maintain temperature, here with everywhere you have heater, you can maintain the temperature. So, here we maintain the temperature, suppose the sample is liquid, as for example. Now, in case of gas chromatograph, we can only analyze the volatile liquid, we cannot analyze the non-volatile liquid. The volatile liquid which can be volatilizes out. So, if the liquid, suppose I want to use the acetic acid. The acetic acid has a boiling point is about 121 degree centigrade. Now, the temperature of the injector should be more than 121 degree centigrade, because as soon as we inject this acetic acid in the injector, this should be vaporized out. And once it vaporizes out, then what will happen? This carrier gas will bring the material here. So, here I have column. Column is like this, it may be capillary, it may be pack column. So, when it the column comprises of different packing material, when it pass through the column, the different component present in the sample, that will be separate from each other, and then it comes to the detector. Here also we maintain the temperature, everywhere we maintain as per the required temperature, and temperature should be higher than the boiling point of the sample that we are going to analyze, because if it is lower than boiling point, there is a possibility of sedimentation or condensation of the particular liquid in the column. So, we shall have to keep the temperature higher than the boiling point of the liquid. Then the detector that detect that particular component A, B, C, D, whatever is that, one after another goes out like this. So, here you have the kind of electrodes, and through the electrode it passed through and connected with kind of a Wheatstone bridge arrangement, where there is a change of voltage or there is a change of current. On the basis of they detect that what are the different components present in the mixture. So, this is largely used, this is called gas chromatograph. In the liquid chromatograph, this mobile phase will be liquid. So, you hear the only the advantage of this liquid chromatograph, that we can analyze both the volatile and non-volatile the component present in the liquid. Whatever suppose I can give the example of glucose. So, glucose is a non-volatile organic material. So, this cannot be separated in the gas chromatograph. Now, if you want to find out that what is the glucose concentration present in the sample, we can pass through the liquid chromatograph, and then there we can find out. I can give this different example of citric acid also. Citric acid is a non-volatile acid. So, that also you can find out the different type of protein also we can get analyzed in the liquid chromatograph. Now, eluent, the fluid eluent is the fluid entering the column or solvent that carries the analytes, and eluate is the mobile phase leaving the column, that which is leaving the column, that is the eluate. The stationary phase is the immobilized phase, immobilized of the support particles on or on the inner wall of the column tubing. As for example, we have silica layer, thin layer chromatography, then we have silica gel, alumina, like this. We have different type of packing material we use in the column. Now, we have mobile phase. As I told you, mobile phase, we have liquid, we have gas. Gas we use nitrogen, hydrogen, we use helium. The mobile phase moves through the chromatography column, the stationary phase, where the samples interact with the stationary phase and is separated. The retention time is very important as per gas chromatography is concerned. That time required to separate, because when the sample is coming here, then suppose sample contain A, B, C, D different component. First A suppose is coming, then B will come. See, now initially what you do, we shall have to find out what is the probable component present in that sample. So we can use the pure sample to inject, and then we find out that at what time this is time and at what time the peak is coming. This peak, we can find out this peak is coming at what time. This is called retention time. This is the what we call retention time. The retention time of a particular component that varies from each other. It depends on the characteristics of the column also. Sometimes it may so happen that depending on the characteristics of the column is such that both AB has same retention time. They are very close to each other, so they cannot be separated by using that. In that case, you have to use the different other column which can separate A and B from each other. Then and only then you can get the different peaks. Until unless you get the different peak, you cannot say correctly how much amount of A present in the sample, how much amount of P present in the sample. So this retention time is very important. Time takes for a particular analyte to pass through the system from the column inlet to the detector under the set conditions. The sample, the substrate analyzed in chromatography, that is the sample we do, solvent, any substance capable of solubilizing another substance, that is we use as a solvent. Now the visual output is the chromatograph, because as I told you that this chromatograph, maybe this is on the basis of two type of detection. We have either potentiometric or amperometric. Mostly we have the potentiometric, and through the potentiometric we can note the change of voltage. This voltage and this we correlate the concentration of the different component present in the reaction mixture. So maybe we have some microvolt here, the change of this we correlate with the kind of concentration of the component present in the sample. This is the visual output that we have. The separation, different peaks and pattern of the chromatogram correspond to the different components of the separated mixture. Now, as I told you that here the picture is very clear. Suppose this is the mixture of two particles, and this you can see that that configuration of the two particles are different. One is triangular and another is square. So when it passes through the column, the one is separated from others, and so you will get the different peaks, because first might be triangle is coming and second is the square is coming. So you have two retention time. So two components has two retention time. So if you know when you inject the standard, you find out that what is the retention time, what is this component stands for, and what is the component stands for. So with respect to the standard, you have to find out that what is that. Then you have to first you have to identify what are the different components present. Then you have to inject the desired amount, because this chromatograph is used for dual purpose, for qualitative analysis and quantitative analysis. Qualitative analysis, we find out that what are the different possible components present in the sample, and quantitative analysis means how much of the different component present in the sample. When you do any kind of want to do the quantitative analysis, then we inject the standard sample with desired concentration. With respect to that, we find out how much concentration of that particular component in the sample. Now, this is schematically it can be explained. The flow diagram is like this: mobile phase supply, the sample system. Then here, suppose you have gas, or if the liquid whatever you have here, you put your sample, then it goes to the column, and that present in the column oven. That is, I told you that everywhere we have we maintain the temperature, because we maintain the temperature in such a way that the samples should not be condensed in any different part of this particular chromatographic system. So, we pass through the column where the different component will be separated out, then we detector, and after detector we have potentiometric recorder and computer data acquisition and processing system. That is how we can monitor the different concentration of the material present in the samples. Now, the characteristics of the material is basically they are different. There might be two type of column we mostly use. One is called packed column, and another is capillary column. The capillary column is we can see the capillary column is quite long, and so on the basis of when it passes through this capillary column, the different component present there will be separate from each other, and this is the packed column. This is usually made of stainless steel, and this is made of polymeric material, and this is made of stainless steel. This is comparatively this is a bit shorter, and this is very longer. This is we have this, and then that how the particles they separate from each other, that ion exchange, reverse phase, hydrophobic interaction, sizes, inclusion, and affinity. The different type of techniques that we have through which the particle can separate from each other. Affinity, that this suppose the sample contains two type of particles, but your packing materials, the affinity for this only. So, other particle will separate it out, and then you use some kind of eluate, so that it deters this from the solid surface. You get the pure this component in your liquid. Though here you see this is size exclusion, that you have bigger particle and smaller particle. When it passes through this, smaller particle will be separated out, will be added here, and bigger particle will go out. So, and then you can separate from bigger particle from smaller particle. Now, here the reverse phase and hydrophobic interaction, through which also we can easily separate out the particles from one after another, and ion exchange also we can analyze. So, what I want to tell that in this particular lecture, I try to concentrate that two different techniques largely used by the biochemical industries for in the downstream processing, particularly liquid separation techniques. I told you that penicillin industry is largely used because we use the butyl acetate or amyl acetate to separate the penicillin from the fermentation broth to the solvent phase, and then I told you at the same time that streptomycin is used by using some kind of chromatographic technique, because just to separate we use the column through which the streptomycin is specifically absorbed, and we use the sulfuric acid as the element. We take the streptomycin sulfate as the element. So, then we have I told you the distillation technique, where that like ethanol is separated on the basis of the particular boiling point of the particular solvent present in the mixture. So, on the way we heat it, and then we pass it through the distillation column at different temperature. We can separate out the different fractions, and we can have different solvent in the system. So, this is all about the downstream processing, and from that we have a clear cut idea that the different downstream processing has the different conception and different way of separation that we have. So, that is how different biochemical industry they differ from each other, because all the biochemical industry, they have different downstream processing, and they don't have the same type of downstream processing. Depending on the nature of the product, they have to adopt the downstream processing accordingly. So thank you very much.